In this video, I'll show you how to solve the ALEKS problem called drawing the Lewis dot diagram of a main group atom or common atomic ion. This problem is going to ask us to draw the Lewis dot diagram, or symbol, as I call it, the Lewis dot symbol, for either a neutral atom, a cation, or an anion. I'm going to show you how to do all three. The Lewis dot symbol is a representation of the atom that shows the number of valence electrons in that particular atom or ion. Shows the number of valence electrons. So in order to be able to draw a Lewis dot symbol, you need to know how many valence electrons are present in that atom or ion. And so to do that, we're going to take a look at the periodic table, kind of remind ourselves of how we find the number of valence electrons in an atom. So I'm scribbling some stuff out here on this particular periodic table. The group numbering system that uses the letters 1A, 2A, 3A, 4A, etc. If you're looking at that numbering system, the number associated with each one of those group names, so group 1A means that the elements in this particular column they all have one valence electron. That's what that 1 represents. In group 2A, these elements all have 2 valence electrons. Again, that's what that number represents. All of the elements in this column here, they all have 3 valence electrons. You get the idea. There is one exception to this rule, and it is helium, which is kind of cool that that's the example that I was given to work on here. So for this particular column, all of the elements, neon and below, they all have 8 valence electrons, just like we would predict. I don't really have room to write valence. 8 valence electrons. So all of these guys have 8 valence electrons, just like we would predict based on the numbering system. Helium is the one exception. It only has 2 valence electrons. Now don't worry, because helium is the only element on the periodic table that doesn't follow this trend. So it's the only one that you have to worry about. All the rest of them follow the trend. To write the Lewis dot symbol, we start by writing the atomic symbol. So for helium, that's capital H, lowercase e, and you're going to do that by clicking on this button in your little toolbox, and that'll give you, click on that and then click on the drawing space over here, and that'll give you the opportunity to type in helium. Then we are going to represent the number of valence electrons for helium. We're going to represent those valence electrons using dots. So it shows the number of valence electrons using dots that go around the atomic symbol. So we're going to draw dots around the atomic symbol, and we're going to draw the dots in a very specific way. So let's say that we just have some generic element X. We're going to represent the valence electrons of this element using dots in the area around the symbol. We do this by starting in the 12 o'clock position and putting a dot to correspond to the first valence electron, and then we move to the 3 o'clock position, and then the 6 o'clock position, and then the 9 o'clock position, and then we go around the circle again, and we fill in as many dots as we need to, up to 8, which is the maximum number. So if an element has 1 valence electron, its Lewis dot symbol would look like this. If an element had 2, its Lewis dot symbol would look like this. If it had 3, it would look like this. If it had 6, 4, 5, 6. It would look like this. So basically you're going to draw 1 in each position before you pair any of them up. There is an exception to this rule also, and it is our friend helium. Helium is the only exception to this rule. With helium, both of its dots, both of its electrons are paired together, so they are both drawn side by side instead of drawn separately like normal, like we would predict. And again, helium is the only thing that violates these rules. So this is what the Lewis dot symbol of helium looks like. Let's do a couple of other elements that are more normal, just so that you would know what a normal one looks like. So let's say, for example, what if we were asked to draw the Lewis dot symbol of a neutral atom of nitrogen? What would that look like? So first of all, we're going to write the symbol of nitrogen. And then we're going to find nitrogen on the periodic table. We're going to pay attention to what column it's in. It's in column 5A. That means it has 5 valence electrons. We need to draw 5 dots around that nitrogen, starting at the top. 1, 2, 3, 4, 5. In case you can't guess, haven't already guessed, these 2 buttons here are how you would fill in those dots. for the Lewis dot symbols. The one on the left fills in just a single dot at a time, and this one fills in pairs of dots. So this is what the Lewis dot symbol for nitrogen would look like. Now, what if it asked you to do this for an ion? Like, let's say that it asked us to draw the Lewis dot symbol for an N plus ion. This is a cation. So for a cation, a positively charged ion, that is something that has lost valence electrons, and the number of valence electrons that it has lost is indicated by its charge. This guy with a +1 charge has lost one of its valence electrons. What does that Lewis dot symbol look like? Well, instead of 4, it's lost 1. Instead of having 5, it's lost 1. It only has 4. So 1, 2, 3, 4. If we're drawing the Lewis dot symbol for an ion, we do need to indicate the charge of the ion with this Lewis dot symbol. And the convention that we do for showing charge is to put square brackets around the whole entire Lewis dot symbol and then write the charge on the outside of the square brackets. Notice that you have over here a tool that lets you just click square brackets right into place. If you click on this and then click on your drawing, it's going to pop that bracket into place, and there's going to be a text box in this spot where you can enter in the charge. What if, we'll do one more example here, what if it's asking us to do this for an anion? Let's pick a different element. Let's say it wants an anion of S2 minus. What would that look like? Now, an anion is something that has added more valence electrons. Has gained valence electrons, and the number of valence electrons that it has gained is given by the magnitude of the charge. In this case, it's gained 2 electrons. So there's sulfur. Let's go find sulfur on the periodic table. Let's see what it normally has. Sulfur normally has 6 valence electrons. Let's just start with that. 1, 2, 3, 4, 5, 6. Because this is an anion with a -2 charge, we need to add 2 more. Don't forget square brackets and the charge.